Hello everyone. Hello everyone, Mr. Raji. Today I'm gonna do my final exam. The material is about genetic algorithm. So let's further ado, let's continue. Okay. The first is before we know deeper to the genetic algorithm, we must know what is the history that make genetic algorithm for nowadays. And this is there are two men that make this genetic algorithm. As the first is John Holland. In 1962, John Holland's work on adaptive system laid the foundation of later developments. And then in the 1975, the publication of the book Adaptive in Neural and Artificial System by Holland and his student and colleagues. And the last one, early to mid 1980s, genetic algorithms were being applied to a broad range of subjects. And after we discuss about John Holland, the second man is another man that e- evolved the genetic algorithm. His name is John Gosset. In 1992, John Gosset used genetic algorithm to evolve program to perform certain tasks he called his method genetic programming. And because these two men nowadays they have a genetic algorithm method. After that, I'm going to explain the definition of the genetic algorithm. Genetic algorithm is a particular class of evolutionary algorithm that use technique inspired by evolutionary biology such as inheritance, mutation, selection, and crossover, also called recombination. The evolutionary used usually start from a population in each generation. The fitness of every individual in the population is evaluated multiple by individual are selected from the currently population based on their fitness and modified to form a new population. The new population is used in the next iteration of the algorithm. Now after that, the first step, the population. After the selection, the third is crossover, and the fourth is mutation. After this step, I'm gonna explain more deeper about what the meaning of the each step. The first step is the population. The source is the definition from the population I picked it from the KBBE. The first definition is the entire number of the people or residents in an area. The second is the number of people or individuals who have the same characteristic. The third is the number of occupation, both human and other living creature in the particular space unit. And after that, there's a selection. Selection is we randomly use a base Bayesian select of the subset the individual based on the fitness. This is the example, the picture. Before is the population. After that, we're gonna select it with the different characteristic. And after that, the crossover. The crossover is the mate strings for crossover for its couple. We first decide if we decide to actually perform the crossover, very randomly extract the crossover point. So result is before is 110 and S2 is 101 up and before after the crossover it's become 101 and 110. This is the example. This is the selection part and this is the crossover part. It's gonna mix it them together. After that the mutation. Mutation is the final step is to apply a random mutation for its byte that we are to copy to the new population. We allow a small probability of error. Is for example, the initial string is 1, the after mutation is 0. This is the crossover part. This is for the example. The crossover part is the initial, the number is blue, and after mutation, the number is the color is gonna be green. So for example, for it orange, after that green. Method of selection. In genetic algorithm, there's a lot of method of selection, but in this presentation, I'm going to explain just three methods of selection. The first method of selection is roulette wheel selection. The roulette wheel selection is we're gonna uh, make the individual uh, individual what I can call it individual population gonna fill it in the wheel. And then this, for example, the population number 1, 2, 3, 4, and 5. And after that, we're gonna spin it, the wheel. After we spin it, the wheel, and when the wheel stops, the selection point is gonna pointing at the group. Like this, the pointing at group number 3. And after the rule of wheel, the method of selection, the number 2 is rank selection. For the example, this is the picture. The chromosome 1 have the biggest value on this diagram, and after chromosome 1, there's a chromosome 2 that uh, have the big chromosome, big value. We compare it with the chromosome 3 and 4. After that, there's a result. The biggest value is from chromosome 1, the second biggest value. The second rank is from chromosome 2, and the third rank from chromosome 3, based on the biggest value. And after the rank selection, there's the additive selection, the number 3. The additive selection in each part have to have the same value, like this, like P1 to P5. Value is P1 to P5. So this is must to be P1 to P5. Cannot be P1 to P6 or 8. And if this parent have the same value, then we can do the offspring, make a new population. This is the case study. Case study is we're gonna select where the nearest distance to where we're gonna go. If we are from the place number 8, we're gonna go to number 3. We can go to the place number 8, number 4, and then number 3, or we can go 8, 2, 1, and 3, or we can go 8, 7, 6, 4, and 3. And this is in each place there have a distance like 8, place number 8 to number 2, there's the distance is 15. 8, place number 8 to number 7 have the distance is 20. That And after that, we're going to discuss about code-based visualization. This is the code for make it real. So first we must calculate the total distance. Like, for the example, this distance, number 8, number 2 is 15 distance. The distance is 15. Number 2 to number 1 is the distance is 15 too. And the number 1 to number 3 is the distance is 10. And when we calculate it together, it's become 40 because 50 plus 50 is 30, and 30 plus 10 is 40. After we calculate the distance, we're gonna initialize the population. But if in each place there is no population, we can skip it. This is the selection part. We start parent 1 and parent 2 is the place number 1 and the place number 2. Then we're gonna count the length. This is the child. The child is after the place that we select. So that's the function. The envelope uh, this is parent 1, parent 2 is the place number 1 and number 2. After that, this is the main function to run the genetic algorithm. The genetic algorithm. The main function to run the genetic algorithm. This is the code. And after that, for using it, with the number of cities, how many number of cities, and then the distance, the genetic algorithm, the individual, the corresponding parameter. Next, etc. Genetic algorithm is same as pair technology. What is the benefit to learning biotechnology algorithm? The first is concept. Is is easy to understand, modular, separate from application, support multiple object optimization, always an answer get better with time. The fourth is easy to exploit prefers or alternative solution, and the five is flexible building blocks for hybrid application. This is all for me. Thank you for watching. I'm very sorry if I have a miss a pronunciation or misspelling the word. And thank you for enjoying it. And yeah, thank you and goodbye.